Hello, fellow apes. I mean, fellow AP environmental science students. I'm Utsaw Singha.
And I'm Cameron Smith.
And we will be talking about photovoltaic solar cells. We will be explaining its uses and potential to improve the world. So what are photovoltaic solar cells, or PV? Well, its literal definition is a system of capturing energy from a sunlight and converting it directly into electricity. Photovoltaic solar cells are used in solar panels where arrays of PV solar cells are used to produce electricity. Although they produce relatively low voltage, those direct currents are converted into higher voltage alternating currents for use in homes and businesses. Typically, PV solar cells are 12 to 20% efficient in converting sunlight into electricity, but as this conversion of energy doesn't require fossil fuels, it's much cleaner than other forms. Well, that's cool and all, but how does it work? It's kind of complicated. Photovoltaic cells work by allowing photons, or particles of light, to knock electrons free from atoms, generating a flow of electricity. And as said before, solar panels are comprised of PV solar cells. Each photovoltaic cell is basically a sandwich made up of two slices of semiconducting material, usually silicon. To work, photovoltaic cells need to establish an electric field, much like a magnetic field which occurs due to opposite poles, an electric field when opposite charges are separated. This occurs by seeding phosphorus into the top layer of silicon, which adds extra electrons with a negative charge to that layer. Meanwhile, the bottom layer gets a dose of boron, which results in fewer electrons or a positive charge. This all adds up to an electric field at the junction between the silicon layers. To finish the system, metal conductive plates on each side of the cell collect the electrons and transfer them into wires. At that point, the electrons can flow like any other source of electricity. So what is the main goal of this technology? Of course, one of its goals is to make the process of creating energy cleaner. The goals of Solar Energy Technologies Office, or SATO, are to develop the technologies and knowledge base needed to continue the sweeping cost reductions seen throughout the energy since 2010, and to improve the ability of solar energy to integrate into the country's electric grid. SATO are one of the leaders in improvement on integration of solar technology. Their plan is for residential PV to cost 5 cents per kilowatt hour, 4 cents per kilowatt hour for commercial PV, and 3 cents per kilowatt hour for utility scale PV by 2030. Compared to right now, where the cost is 60 cents for residential, 11 cents for commercial, and 6 cents for utility scale.
As of right now, the most popular use for creating energy is coal or natural gas combustion, followed by nuclear fission. Combustion releases greenhouse gases, and nuclear generation creates radioactive waste. Photovoltaic solar cells create electricity using daylight, not fossil fuels or radioactive materials, and are much safer than both combustion and nuclear. Solar panels can also be installed in easy places such as house roofs, where daylight is abundant. The energy harvested by this conversion can also be stored and later used so energy isn't wasted. Therefore, PV cells have huge potential. Well, as this source of energy isn't nearly as popular as combustion and nuclear, that means that there must be some obstacles holding it back from its true potential. For one, solar panels are more economically feasible in rural areas where the homes are already connected to the electricity lines. But when a house is near the grid, it has a very long payback period, up to 20 years. But after it is paid back, the cost is almost free to maintain. In addition, it is also very expensive to both manufacture and install the panels. But engineers are trying to overcome this by seeking better and cheaper photovoltaic materials. To counter this, the United States instituted tax breaks, rebates, and funding packages to make solar energy more affordable. But just because these cells don't release greenhouse gases doesn't mean that they don't have environmental costs. The manufacturing of PV cells require a great deal of energy and water, involving a variety of toxic materials, although newer solar cells are less reliant on such substances. The batteries used to store the piled energy also have environmental costs associated with the manufacturing, disposing, and recycling of batteries. With the cells themselves at the end of their life, the disposing and recycling of PV cells can be an environmental problem. But experts and critics both believe that these cells will have the lifespan of 30 to 50 years with a promising source of energy.